This is section 1.1, day 3, our third day of kind of working with equations of lines. Today we're going to move into a lot more of parallel and perpendicular. So just to recap, parallel lines have the same slope, exact same. So just to give you an example, if one of them was 5/4 and the other one has to be 5/4, so to be exactly the same. Perpendicular lines have opposite reciprocal slope. So to give you an example of that would be if it was negative 5/4, then the opposite reciprocal would be, opposite means change the sign, plus for minus, and reciprocal means flip the fraction. So we are currently negative, we would turn positive, and instead of 5/4 we would be 4/5. So perpendicular means completely flip the fraction and change the sign. So just to try a couple, first one says write an equation for a line that goes through 1, -3, and is parallel and perpendicular to this one. So we've kind of got a two-part problem. One side's going to be parallel, one's going to be perpendicular. So before you can do anything, you got to know slope. And they gave you an equation of a line, a really pretty line. And this one already exists. So this 2x plus 3y already exists. It kind of looks something like, I'm quick solving here. This is a half, that's a pretty small deal, and then it would look like this. Okay, so there's already a line that exists, and what our job to do is to draw or write me an equation that is parallel to that, and it has to go through 1, -3. So our parallel line will look like that, and then our perpendicular one will look like that. So we are writing two more equations that actually the only thing that they will have in relation to this one is the slope. We'll have a new y-intercept for both equations. So before you can do parallel or perpendicular, you need to know what slope you're working with. So in the ridiculous tiny amount of space I left myself, I'm going to take 2x plus 3y equals 1, and we need to solve that for y so we can figure out what our slope is. We can't just use the 2, because in order for us to pick out slope, we need to have it in the form of y equals mx plus b, and we need to be able to see the slope. So I'm going to subtract 2x over to the other side. I will have 3y equals 1 minus 2x. And then I'll divide by 3. And everything gets divided by 3, so make sure that you do the 3 the whole way across. So the slope that we're looking at is a -2/3, and in order for me to be parallel, then my answer would have -2/3 as the slope. And our job now is just to find the b. When I go to do my perpendicular one, the slope will change to be 3/2, flipping that and changing it from negative to positive, and I need to find a new b over there as well. So once I've established my slope, then I can take my point and plug it in for x and y. That's your x, that's your y. So I'd have -3, -2/3 times 1, and then plus b. And we will solve that for b, and we'll have our new value to plug in right there. So -3 equals -2/3 times 1, which is just -2/3, and then plus our b. I don't mind when you're doing these if you want to work in fraction or in decimal. Doesn't matter to me either way. But here you're going to be adding 2/3 over to the other side. And so your b ends up being a -2.3 repeating. So I'll put my -2.3 repeating, and then I've got my answer. That does not look like a 0.3. We'll make that a little better. For perpendicular, it's the same exact process. We just changed our slope to begin with. So I'm going to plug in a -3 for y, a 1 for x, and I'm finding my new b given these values. So I got 3/2 over here plus b. We're going to subtract that over to the other side. So I'm subtracting, essentially 1.5, and I would end up with -4.5. And there's my perpendicular. We're going to do the exact same thing again. I'm just giving you a different equation to use. And I'm going to start by finding the slope before like that last one, I didn't leave myself any space. So I'm going to divide by -4 right away. I'm trying to solve for y, so that way I can see what my slope is. And once this cancels, what I really care about is just this part, the part with the x. I don't really care about the y-intercept because I'm not going to get to use it. I have to find a whole new one. So my slope is -5/4. So I've got my parallel that I'm going to find, and then my perpendicular. So we'll do one of each. So for parallel, it's going to be y equals mx plus b, and I'm going to put my -5/4 there. For perpendicular, it's the exact same formula, but this time my slope is going to flip to be 4/5. We're going to take our point and plug it in. So I've got -8 and 4. 4 goes for the y, -8 for the x, excuse me. And like I said before, if you want to work with these in fractions, that's great. If you want to work with them as a decimal, that's fine too. This one ends up being 10 plus b. So when I subtract that 10 over, I end up with negative 6. Over here, we still got to plug in the same point, so another 4. Only this time your slope is flipped. And you are trying to solve for b now. And we end up this time with a negative 6.4. So we'll add that over, and we get 10.4. So just when you're doing parallel and perpendicular, first pick out your slope, put that in the spot, then take your point and plug that in, making sure that parallel has same slope, perpendicular has opposite reciprocal. I'm just going to recap how to graph with you. I'm going to show you a couple of different ways. I don't know which way you'll prefer. It doesn't matter to me which way you pick, just as long as you know how to graph. So for this one, I'm just going to pick an XY chart, which is very typical of kind of your mathematical education so far. You like to make XY charts. And I would pick a negative number, always pick 0, and then pick a positive. So those are usually the 3 I pick. I'm going to plug a negative 1 in here. That would give me negative 4. And just solving for y, I'd add 4 over, get 12, divide by 2, I'd have 6. Put a 0 in, that's a bit easier. That whole term disappears, and I would just divide by 2 and get a 4. Put a 1 in there, and I would have 2y and plus 4 this time with an 8. So when I subtract it, I'd have 4 divided by 2 is 2. So negative 1, 6, way up there somewhere, 0, 4, and then 1, 2. And our line would look like that. Another way that you could do it is lots of people like to solve for y, like we were doing up above, because then you can pick out slope and y-intercept. So if I move the 4x over and then divide by 2, this is my y-intercept, that's where you would start, and then your slope is down 2 over 1, so down 2 over 1. And then you can connect, and that's another way to graph. The last way to graph is something called graphing by intercept, 2y plus 4x equals 8. And what you're essentially doing is just doing the xy chart for this combo. So a 0 and then a 0 over here. So if I plugged a 0 in for x, that term would go away completely, so I'm kind of just covering it up. Mentally doing the math there, that would be 4. And if I did the same thing with the y, covered that up, mentally doing the math there, I would get a 2. So it's a little bit faster to graph. Don't have to do an XY chart. I mean, you can. You can also just cover them up and solve them each. So when you cover up the y, you're essentially letting it be 0, and then you're finding what the x-intercept would be. So a couple different ways to graph, and a couple different ways to write parallel and perpendicular equations.